This is Dr.D Govardhan, Professor and Head, Department of Aeronautical Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are discussing equilibrium of forces. Okay, in the previous classes we learned when the system of forces are acting on a body, all the forces are replaced by single force which will having the same effect on the body. The single force is treated as a resultant of all the forces. If the resultant of all the forces is equal to 0, then the body is said to be in equilibrium position. Or in other words, when the body is at rest, it remains at rest, or when the body is moving with a uniform velocity, it is having same motions because the forces which are acting on it equal to 0. According to the Newton's laws of motions, the resultant of all the forces acting on the body in equilibrium is 0 now. The resultant of coplanar system of forces acting on a body is 0 when the algebraic sum of the component of forces along each of the two mutually directions is 0. In earlier, when the system of forces are acting on a body is resolved into two components along the x direction and y directions to determine the resultant of all the forces both in magnitude and directions. Hence, in order to get the resultant of all the forces 0, the sum of the component of forces which are acting along the x direction should be 0 and sum of the component of forces which are acting along the y direction also 0 now. And the algebraic sum of the moments created by the all the forces at any point in that plane should be 0. Condition for the equilibrium: when the resultant forces which is acting on a body is 0, that means the body which is at rest, it remains at rest. When it is moving, it is always moves with the uniform velocity. That means sigma f is equal to 0, or sigma f is equal to, we can written as m into a. Since m is not equal to 0, a should be equal to 0. When a is equal to 0 means the body is moving with the constant velocity or uniform velocity. Okay, the procedure for determining equilibrium of forces. First, draw the free body diagram. The free body diagram is the diagram which is free from all the supports, including wall, the surface of the tables, pin, roller, engine, and fixed supports, and keep equivalent reactions offered by that supports on the body. Then the body is said to be free body diagram. And apply equilibrium equations. Generally, these are used for determining unknown forces which are acting on a body. The equilibrium equations are sigma fx is equal to 0. That means the sum of the component of forces which are acting along the x direction should be 0. Sigma fi equal to 0. That means sum of the forces which are acting along the y directions equal to 0. And the moments created by the forces at any point should be 0. These moments created by the forces This equation is only applicable for the non-concurrent forces. That means the line of action of these forces are not passing through a single point. Here, the example I am taking, this body is in equilibrium under action of three forces. One is the weight that is acting vertically downward directions, which is equal to 40 kg. Mass is given. So 40 into 9.8, which is equal to 392.4 newtons acting downward directions. The forces within the cable, it is always acts with respect to the point A away from it. Hence, FB is representing the tension force in a rope AB, and FD is representing the tension force in the cable AD, which is acting in the direction of cable but away from the reference point A, which is shown in figure. Now apply equilibrium equations. Since these forces are intersecting at a point A, two equations are sufficient. Sigma Fx is equal to 0, sigma Fy is equal to 0 to determine the tensions within the rope AD and AB respectively. And the second figure, it is similar to the previous one only, but other end in rope EB, a load is suspended vertically through pulley, which is attached to B shown in figure. Hence, the tension in the rope EB is equal to 40 into 9.81 at an angle of 30 degrees shown in figure. It is an horizontal. The weight we have to determine now, which is acting. Again, by applying equilibrium equations to the body at E, we can determine the weight of the body as well as the tension within the rope ED, which is shown in figure now. Equilibrium of forces, coplanar system. Coplanar means all the forces are lies in a single plane. Here the forces F1, F2, F3 and F4 are there. These four forces, it may be on the horizontal planes or it may be on vertical planes, but that should be lies in a single plane. Then this system of forces are called coplanar system of forces. Here these forces are intersecting at a point O. Hence, these forces are called coplanar concurrent forces. In order to find the unknown quantity, first resolve the forces along the x direction and y direction. The component of force which is acting toward the right side in x direction is treated as positive. The component of force which is acting toward the left side with respect to the point O is treated as a negative force. Similarly, on resolving the forces along the vertical directions, the forces which are acting vertically upward direction are treated as positive. The forces which are acting vertically downward direction are treated as negative. Now take sigma Fx, that means the sum of the component of forces which are acting along the x direction, it should be equal to 0. Similarly, sigma Fy is equal to 0. If these two conditions are satisfied, then the body is said to be in equilibrium conditions. Since these forces are concurrent forces, sigma m at O is not required to determine because the distance is equal to 0, that is becoming, because we are determining its moment at O, that is 0 distance. Hence, that equation is not applicable here now. It is one more example. The 550 newtons is there. It is under equilibrium with the ropes which are attached at A, AC as well as the AB and so on. Here, one rope is making an angle of 30 degrees. Another rope is represented by the form of triangle as shown in figure 4, 3 and 5. That means this is the treated as angle theta. It is also equal to theta now. Hence, sin theta is equal to, we can take it as 3 by 5 and cos theta is equal to 4 by 5. And using these values, we can determine the values of forces which are acting on a body by using equilibrium equations. Equilibrium. When the system of forces are acting on a body, the resultant force can be determined by resolving the forces along the x direction and y direction. The sum of the forces which are acting along the x direction is treated as the x component of the resultant force, which is represented as Rx. Similarly, the sum of the component of forces which are acting along the y direction is represented as Ry. That is the y component of resultant force. The resultant force R is equal to, it is represented as sigma fx whole square plus sigma y whole square under root. Here the resultant force means all the forces are replaced by single force which will having the same effect on the body. Here the equilibrium force is the force which will keep the body in equilibrium position. That means it should be equal to the resultant force but in opposite directions. Hence, the equilibrium is the force which is having the magnitude of resultant force but should act in opposite directions so that the body is in equilibrium conditions. So, the general equations for the equilibrium condition is sigma fx is equal to 0. That is the sum of the components which are acting along the x direction should be 0. Since the forces are resolving along the x direction and y direction and taking sum, that is the component of resultant force as r cos alpha, it is also equal to 0 now. The sum of the vertical forces is equal to sigma y is equal to 0. R sin alpha is also equal to 0. The moment created by the forces at any point in that plane should be 0. This equation is only applicable for the non-coplanar. This equation is applicable for the coplanar and non-concurrent forces. If they are concurrent, the modified equation is sigma fx is equal to 0, sigma fy is equal to 0. But the principles for the equilibrium, since the object is subjected to, depending on its conditions, sometimes only two forces may act, or three forces or several forces may act on it. When the two forces are acting on a body, if the body is in equilibrium position, then the three forces must be equal in magnitude and should act in opposite directions. That is, here one force is acting, that is weight W in downward directions. Here another force is acting, that is reaction upward directions. In order to keep the body in equilibrium conditions under the action of W and R, then the weight of the body should be equal to the reactions offered by the support, or W is equal to R is required. And these two forces must be collinear. That means the line of action of the forces must be lie in a single line. Three force principle. As per this principle, the body is in equilibrium is acted upon by three forces. Then the resultant of any two forces must be equal to the third force, but in opposite directions and in collinear. When the system of forces acting on a body, the equilibrium conditions can be applied to the body to determine unknown forces by using two methods, analytical method and graphical method. Analytical method, Lewis theorem. Here on a body at a point O, three forces P, Q and R are acting. If the system is keeping the body in equilibrium position, according to the Lewis theorem, each force is proportional to the sine of the angle between other two forces. Here, P, Q are the forces are acting on a body at a point O. Alpha is representing the inclinations between the Q and R. Beta is representing the inclinations between the P and R. Gamma is representing between P and Q. According to the Lewis principle, P by sin alpha is equal to Q by sin beta is equal to R by sin gamma. Here I am giving one example now. An electric light fixture weighing 50 newtons hangs from a point C by two strings AC and BC. The string AC is inclined at 60 degrees to the horizontal and BC at 45 degrees to the horizontal as shown in figure. Using Lewis theorem, determine the forces in the strings AC and BC. The solution is here 15 newton the weight of the bulb is given. It is suspended by the ropes AC as well as the BC as shown in figure. Now first draw the free body diagram. The diagram is representing the body which is having the supports like ropes BC as well as the CA that are replaced by the reactions offered by them as TAC and TBC along the direction of the ropes, and weight is acting downward directions, and these three forces are keeping the fixture in equilibrium conditions. Determine the inclination between the forces. Now according to the figure which is given, that space diagram, this inclination is given here 45 degrees is given and the inclination is given 60 degrees. Hence, if you draw the triangle like this, it is also 45 degrees, 60 degrees. That is the inclination at C between TBC and TAC now becomes 75. And here it is the 45 is given, remaining the 90. Hence, total angle now becomes 135. The sum of the inclination the required 360 135 plus 75, it is there. Hence, the remaining angle now becomes 150 degrees. Now apply Lami's principle. According to this principle, TAC divided by sine of 135, it is equal to TBC divided by sine of 150 degrees, which is equal to W divided by, that is 15 newtons divided by sine 75 values. Hence, we can determine TS is equal to 15 divided by sine 75 into sine 135. Similarly, TBC is equal to, we can take it as 15 divided by sine 75 into sine 150 degrees. That is, by using these equations, we can determine the tensions in the cards BC as well as the CA, which is shown in a figure now. Okay, these are the equations obtained and applying Lami's equations for the figure. From this equations, we got the tension in the rope TAC is equal to 10.98 newtons. Similar, TBC is equal to 7.76 newtons. These are the required answers. Types of equilibriums. These types of equilibriums are classified into 3 types. Here, first one is stable equilibrium. In stable equilibrium, the body is kept on a concave surface, as shown in figure. Here, assume it is a ball. Here applied a small disturbable forces on it, P force. But after some times, it will come to its original position. Then the type of equilibrium is called stable equilibrium. In this equilibrium, the weight, which is when it is resolved into 2 components, vertical component and horizontal component, when it is moving in a concave surfaces, this horizontal component always try to bring the body in its original position. This type of equilibrium is called stable equilibrium. That means a body is said to be in stable equilibrium if it returns back to its original position after it is slightly displaced from its position of rest. This happens when some additional force set up due to the displacement and bring the body back to its original position. Here, the horizontal component of the weight of the body is bringing the object to its original position. This type of equilibrium is called stable equilibrium. Unstable equilibrium. In figure number B, when the body is resting on a convex surface as shown in figure, if we apply small disturbable force on it, it always moves away from the original position and it will not come to its original point. This type of equilibrium is called unstable equilibrium. That is, a body is said to be in unstable equilibrium if it does not return back to its original position and yields further away after slightly displaced from its position of rest. Third one, neutral equilibrium. Here I am taking the example, the ball is resting on a horizontal surface. When a small force is applied on it, it displaces from its original position A to B. Again, it will come to its rest position. This type of equilibrium is called neutral equilibrium. The horizontal force which is acting between the surface of the plane and the body is keeping the object in equilibrium position. It's after moving slightly from its initial position A. This type of equilibrium is called neutral equilibrium. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.